Hello, everybody. Is everyone feeling good after lunch? Yeah? Solid? 2 thumbs up? All right. Well, first, big round of applause, everyone, for the organizers. This has been a fantastic conference. I cannot tell you, as a representative of Microsoft, I am just elated, excited to be here. So, as Brent was saying, my name is Ryan J. Salva. I am a product manager at Microsoft. My team is responsible for building mobile development tools, specifically for React Native. So we're the team that owns tools like CodePush or the VS Code extension for React Native development. And I know that on all of your kind of agendas for the day, it said that I was going to be talking about Windows development. I've got a big surprise for you. I'm not going to talk about Windows development. Instead, I'm actually going to be talking to you guys a little bit about debugging in production today. This is really, really exciting stuff that's coming out just here at the tail end of 2016. And so, when I think about these kinds of concepts, I find that it's really, really important to start simple. So I'm going to start with some really basic, fundamental concepts that we're all familiar with, and then we're going to kind of get rolling and get more complex as we go along. Because I'm in this because I love building tools. I love enabling other people to create. And sometimes I know that it's really fun to peek underneath the hood and see how the tools that we use every day actually kind of shape our workflows and shape the way that we create. And it makes us better developers overall. So here's what we're going to do. We're going to start just by taking a look at what we already know, the basic React workflow, right? So you've got some source files, you punch them into Webpack, Webpack spits out kind of a minified file, it then ends up running in V8 or Chakra as the case may be, which then communicates with the DOM via the virtual DOM, right? So that's all in React. For React Native, the process is almost exactly the same. The nouns are just a little bit different. Right? So let's see here. Yeah, here we are. So instead of just having native UI, or instead of having a DOM, we have native UI. Instead of having V8, we've got the JSC. Instead of having Webpack, we've got the packager. And only difference here is that over here on the far side, instead of having just index.jsx, we've got one for iOS and one for JSX. Now, when we're ready to start debugging with this guy, some funny things happen that wouldn't normally happen in a normal kind of React web-based workflow. So first, that debugger, right? He's got to attach over to the running instance. But a funny thing happens here. When it tries to connect to the JSC, that guy just totally denies him, smacks him down flat. Because the thing is that the Android platform, at least the Android platform, does not allow the JSC to run in debug mode. And so instead, we got to find something else to run that JavaScript in that is capable of operating in debug mode. Well, luckily, JavaScript runs everywhere. There's all sorts of places that you can run JavaScript. The most obvious one, well, kind of click on over here. We just need something. Hey, you know what? Chrome runs JavaScript. Chrome's a great place to run JavaScript. Not only does it provide good development tools, but it's also got one of the fastest JavaScript engines on the planet, right? So, what we'll end up doing is when you start up that React Native app and you connect to the debugger, a funny thing's going to happen here. That bundle that is normally operating in the JSC, it's going to be moved over into Chrome, right? So at this point, the JSC is effectively moot. It's out of the equation entirely. All of the JavaScript for your React Native app is now actually running in Chrome during debug mode. So what happens here is that your native UI communicates with the packager, which is essentially at this point a WebSocket server that's relaying messages back and forth between the native UI and Chrome, where all of your JavaScript is running. Then, as you're debugging, communication happens in between Chrome and the packager, finally to kind of output any of the kind of resulting changes that you make during debugging back out to the native UI. So we've essentially removed the JSC entirely from the equation by doing this little magic trick where we move that bundle from one location to another. Now, a cool thing is available to us here. The thing is that Chrome's not the only thing in the world that can actually run JavaScript. Node also does a fantastic job of running JavaScript, right? And so this is actually what we do inside of VS Code when we're establishing a debug session. Rather than run JavaScript in Chrome, instead we choose to run it in Node. So real kind of quick exit here. I'll head on over to VS Code here, where I've got a debug session already set up. And a couple of things that I want to point out here. Let's see if I can get this open here. We've already started up the React packager right here. It's started up. Apparently my computer wants my password. Nobody look. All right, so we've already started up the packager. And here, over in our simulator, we've got an instance of a super, super simple React application up and running, just with a quick little timer. And from here, all of my JavaScript is running in Node in the background, and you'll see that. Let's see if I can get this guy down. I've got a breakpoint set right here. And if I come over here and hit add, I'll instantly hit that breakpoint. So remember here, the magic trick that's happening is that JavaScript is not running in my simulator. It's not running in the JSC at all. It's running in Node. That's going to be really important as we kind of start piling on the complexity here, right? Okay, so we'll head on back to our deck here. Keep going through this. All right. Goes through the motions. There we go. Node. All right. So, you may be asking yourself, if we can perform this magic trick that moves that bundle from the JSC into Chrome or into Node, is that bundle portable? Yes, of course it is. We can move it in all sorts of different places. In fact, one of the big ones here, I bet it could run in the cloud. In fact, yes, this is exactly what CodePush does. What it essentially does is it takes that bundle and moves it out of the JSC or everywhere, and it kind of temporarily stores it up in the cloud. So instead of just having a bundle which is there statically packaged with our app initially, what it's going to do is it's going to move those bundles from the cloud whenever it finds a new version, an updated version, and bring them down into the JSC, and now all of a sudden you've got a new updated app. This is how CodePush has operated for the last year or so that it's been available. What does that give you? Well, there's several different benefits here. Namely, you get to publish your apps faster, resulting in fewer complaints from your customers, because in the end, you get to fix those bugs when they show up. You get to deploy updates to your app as needed on demand, and you can incrementally roll out new features so you're delivering value to your customers more often. So this is a tremendous benefit compared to native applications where you've got to go through the native app store every time you want to deliver new features, new bug fixes, and updated code. But is there a problem here? Well, clearly there's a problem here. So we talked a little bit earlier about, kind of debugging and kind of walking through our code. Well, the thing is that every time we push out a new CodePush deployment, we're delivering new source code. And that bundle right there, that bundle, it's minified, it's inscrutable, it is completely unreadable, and when it comes to stack traces, because that guy, it's just compiled code, right? And so anytime you get an error, you don't have the same kind of benefit that you have with something like Crashalytics or Hockey App, where you've got a symbols file that can decode that for you. What we need is some way to symbolicate our JavaScript bundle. Well, fortunately, there's an answer for that. This kind of diagram that I gave you earlier was maybe only half of the truth. When we moved all of those files into the packager and it spit out our bundle, there's another file that it gave us. It also gave us these source maps, right? And this is a familiar concept to many of us. Now, source maps, they're basically your secret decoder ring that gives you a quick mapping in between your compiled code, compiled and minified code, and your original source code. They're written in this kind of format that's called base64 VLQ, stands for variable length quality. And essentially what it does is it makes a mapping between these 4-digit characters, the CAAA here, right? your source file is filled with all of these things, and each one of them maps to a number, and those in turn map to a location in your source code. So that first number, that's the minified column number. Second one, that's the original file name. Third one, that's the original file row. And last one is, of course, the original file column. Interesting kind of point of interest here. You'll notice that there's only a minified column number there. There's no minified row number. The way that it actually works is the row is built off of the last comma that was in the file. So all you've got is one long concatenated single line row, and each one is built off of the one that comes before it, right? So, in fact, we can take a look at that. Let's scoot on over here to Chrome. Do we see this guy? No, we're going to exit out of this mode. Boom. So you see here, I've actually got a source map file loaded into Chrome, and you'll see, see if I can grab one of these. You'll see all of these little 4, 5, 6-digit numbers. So all of those are included in your bundle, and ultimately those map back to a source map, which then maps back to your original file. These are the key that you need in order to connect that code, that error, that bug that came in your deployed app back to your original source code so that you can figure out what went wrong in your deployed code. So, how do we make sense of this? What do we do with this? What we want to do here is we want to take that original source map and we want to get it up into the cloud with all of our CodePush deployments, right? So if we are able to pair that source map with a CodePush bundle that's in the cloud and that eventually then gets deployed out to all of your customers, all of your end users, we now have the key that we need to decode all of the errors that we see in our Crashalytics or our hockey app or whatever our kind of reporting system is. This is really important. So let's actually see how this works in practice. I've got two things working against me today. One is that I'm jet lagged to all hell, and two is that this depends upon an internet connection. So let's see how this works out, shall we? All right, so the first thing that needs to happen is out of Xcode, we need a release version of our build. So we're just going to do a quick little build right there. That is eventually going to replace the app that is right there. So while that is building, I'm going to come over here and let's find our terminal window. Cool. We're right here. Main.js. And I'm going to start making some changes to this, but not save it. Okay, good. So we got that guy up. And I am going to, just to prove that we've actually pushed a new CodePush version up, I'm going to change the background color of this guy. All right. So now we're going to push a deployment. This is where the internet gods have to be kind to us. We are going to not only need to push that guy up, but also download it again. So again, what I've done here is I've taken an app, I've deployed it to my simulator, then I'm making some modifications in my editor, pushing all of that up to the cloud, and then what I'm going to do is I'm going to suck down the new version into my simulator. So now the code that is in my simulator is no longer the same code that I initially deployed with. Make sense? All right, cool. So it looks like it got up there. Let's try to pull down the new version. Oh, good. We've got a new version here. We're going to install it. Well, that is doing its thing. Okay, good. So we just changed color, so we can see that we've got new code in there. Now the trick is that we need to find out what the source map is for that when we get a crash. So here's what I'm going to do here. These are all the steps you'd have to manually take in order to do this yourself. I'm going to start a log. All right, cool. So we got a log running here. I'm going to force a crash on this guy. Yes, thank you, Xcode. The important thing that came out of that crash is this right here. What you're looking at here is the stack trace, the JavaScript bundled stack trace for that error. So I'm going to take that guy over into my project, and I'm going to save it in a JSON file called stacktrace.json. We got to do a little something here to make it JSON friendly. That's all good. Replace all. You guys tired of looking at code? You want more cats? You can probably make more cats happen. All right. So now we've got the stack trace, but we also need that original source map that was in there, right? We need that bundle. So we're actually going to grab that here from Chrome. This is the same bundle, if you will, that was deployed in that CodePush. This is the exact same bundle that was uploaded to CodePush and is now living on my simulator. This one takes a couple seconds to load. Cool. So now we've got the bundle. We've got the stack trace for our crash. I'm going to bring this guy back over here into, oops, wrong one. Into map, save. And now that I've got all the components, I've got the stack trace, I've got the original bundle, I've got the source map. From here, I can use my secret decoder ring, which is this quick little file here that essentially goes back and pairs up all of those base64 VLQs against the source code. And I'm going to run that as a node script. So node map.js, and here we go. Here you'll see our stack trace for this guy. This is telling us, what happened at each line. Now at require 97.js, there was an error on line 1, column 0, and so on down the line. Now, that was a lot of work to find out what our error was. If you actually wanted to kind of get all the stack traces via Google Analytics or whatever, and you got those stack traces, you would have to have saved the source map for all of your deployments, all of your files. And this is not a problem that's unique to CodePush. It's unique to any React Native app. To actually do the debugging, to figure out where the errors are in production is a huge pain in the derriere, pardon my French, because it's bad French. So, not even a pity laugh? No? All right. Cool. So, that's a lot of work. That's a lot of work. How can we sidestep that? How can we make that easier? Well, this is where I want to introduce you guys to CodePush vNext. So, CodePush has been around for about a year now, and while we've worked very hard to kind of make it more reliable, make it more stable, make kind of the internet, or make the connection speeds faster throughout the globe with more data centers. In terms of feature growth, there hasn't been quite as much. Later on this year, in 2016 and the first part of 2017, we're going to be introducing the next version of CodePush. And for this, we're actually marrying it up with Hockey App. Hockey App, many of you may already know and use. It essentially provides not only beta distribution for your app, but also crash reporting. But historically speaking, it's only provided that crash reporting for native iOS and native Android apps. So Later on this year, we're going to be providing the next evolution of CodePush and Hockey App, which essentially embeds those source map files with all of your CodePush deployments. So what you end up getting is not just kind of on-demand deployment of your code anytime, anywhere, anyhow you want to, but you also get an error reporting system that helps you better understand what's happening to your app in production, how you can actually kind of tie those deployments back to bugs, back to users on devices, and hopefully improve the overall quality of your app. So today, I'm announcing a private beta of CodePush vNext. I encourage all of you to apply to it. There's a URL right here, aka.ms/CodePush vNext. Please visit, sign up. I would love to have you and to use it, to share with us your stories, and to be among some of the very first people to give us feedback on it so that when we bring it public, it's as awesome as it possibly can be. All right, so that's all that I've got for you today. In order to see the product yourself, you'll have to sign up. From here, I would love to take questions and talk to you guys. Why do I use Mac? How many times? 945 votes. That's impressive. Sweet, knocking down. So I use Parallels on my Mac. I use Mac because I need to be able to build for iOS. That's why I use a Mac. So, in fact, those of you that want to, I've got an entire blog post about it. You're welcome to visit me at spacecat.rocks or ryanjsalva.com. What does proxy mode equals on mean? So that's not a, I'll call that pseudocode. That is not actually what is in the code. What that really means is just that your React Native app is running in kind of a virtual proxy mode that skips over the JSC and moves the bundle over to Chrome or Node or whatever the kind of the running instance is of your Node server. I'd love some Windows stickers for my Mac. Do I have some? Didn't bring any Windows stickers. Sorry, guys. So will it work on the Windows machine? Yes, absolutely. It's completely platform agnostic. I know that I know that I'm running a Mac, but both the CLI and the service itself will run on a Mac. How many applications written with React Native Microsoft has in production? I'm going to assume by this that what you mean is apps, Microsoft apps that consumers use. Not many today. Today, our focus is primarily on building tools to enable developers. Frankly, you guys as a community are moving so fast that it's hard to keep up. And the stability of the platform isn't yet at a place where we think that we can put something like Skype or Outlook on React Native. Our teams just aren't able to keep up with the stability of it and the pace of it. I can tell you that there are a number of teams, some of the names I've already mentioned, that are starting to build with React Native, but they don't have their apps in production yet. App Store approval process is okay with upgrading source code from the cloud whenever. Yes, I've got another version of this deck that actually has a snippet from the Apple terms and conditions. And they very explicitly allow, I forget what their phrase for it is, but it's unmanaged code, I think is the phrase they use. So any code that is not managed code can be updated dynamically. Fortunately, any JavaScript, whether it runs kind of in the JSC or in a web view or the like, is all fair game. And so CodePush is 100% above board. We have thousands of apps in deployment that are using CodePush today from developers like you. In fact, I'm sure if you turn to your neighbor, some of them already have it. Does this architecture provide ability to remote debug the production app? No. What this allows is essentially post-analysis of the app. We do have a product that aims at production debugging. It's from the guys over at Glimpse. I think it's GLIMPSE. But that is aimed today at ASP.NET applications and not at React Native applications. I'm in talks right now with that team to kind of borrow some of their same concepts and move it over to React Native within my team. Why do I use Chrome and not Internet Explorer? Because there is no Internet Explorer on a Mac. Really, guys, it is 2016. Let's see here. Do I use TypeScript with React at Microsoft? Yes, absolutely. In fact, some of the aforementioned teams that are building large-scale apps with React Native are using TypeScript with it. We are doing a lot of active development right now to improve the TypeScript experience with React Native. In fact, my team just updated all of the React Native typings that essentially provide kind of the better IntelliSense experience and better kind of in-editor experience working with TypeScript and React Native. That was a one-time manual update that we did of all the typings. We're presently working on borrowing some code from the guys over at Aurelia to dynamically update the typings for React Native using a tool that they built for their framework. Looks like a harsh debugging process. Do you have tools for that at Microsoft? Depends upon what you mean by harsh debugging process, which part of it. I'd like to point out that all of that middle part where I came up like showing how much of a pain in the derriere it was to kind of get to your source maps, that's the problem that we're solving. That's the problem that we're trying to solve. You should not have to do any of that copy and paste to connect your source file with your source map with your bundle. All of that should be taken care of for you by the tools, and this is what we intend to deliver with CodePush vNext. What do I think about Sentry? So Sentry is doing some cool stuff. They're actually really thinking along the same lines as we are right now. They had a release that came out only, I don't know, maybe about 2 weeks ago that starts to do some of the same stuff that we intend to release this later this year, and that's in the private beta. The difference is that today they do not have managed code stack traces, and that is something that is available within ours. Does it work in Windows Phone? You know what? The number of people that are using Windows Phone is relatively small, and so we have not yet made an effort to support it. Applause for that? Really? That's kind of low. That's low. All right. Let's see here. What's the current state of React Native on Universal Windows Platform? When is it ready for production? So that one's an excellent question. So the community that really stood up and contributed to the Universal Windows Platform on React Native was a relatively small community. All said and done, the vast majority of the heavy lifting was done by about maybe 6 to 10 developers, something like that. I think maybe even less than that. So they are currently in a place where they are looking at other areas to invest. And so for the Universal Windows Platform to evolve on React Native, it's going to really take community support from folks like you who want to see it. We've got it to a place right now where it's fairly stable. It's just not very complete. And so if you want to expand that and you want to do more with Windows, I encourage you guys to contribute. We are actively accepting pull requests.
All right, this is our last question.
Last question. I better be a good one then. All right. So remote code execution. How can I be sure that bundle from cloud is actually mine? There is an API key that is associated with every app. The documentation for the security model is online. I encourage you to go check it out at codepush.tools. But long story short, we've got a lot of customers who are very, very security conscious about their apps in production. And so this thing is locked down like a mofo. So awesome.
Cool.
Great. Thank you guys so much.